Well, hi, welcome back again. So, this is the second of the 5 wave behavior videos. These are little mini lectures that I'm giving during class. So, you're either maybe you missed class or you're watching it again because you needed to see it again. But the first one was all about interference. That was the last or the first 2 videos that I made. This one is reflection. There are 3 more after this: diffraction, refraction, and the Doppler effect. Okay. So, like I'm doing with the other ones, I want to show you what this looks like first on my virtual little wave pool, what we call the ripple tank. And I think this one, probably of all 5, will be the easiest one for you to relate to because it's something similar to what you've seen before with particles. So let's take a look at an example of reflection first. Okay, so here are what we've seen before. These are nice plane waves. We call them just straight waves, like making little waves in a pool or something like that. And they're going to move downward on the screen. And what you really can't see probably well here is I put a little wall in the way. So these waves are going to hit the wall and they're going to reflect. So let's get the waves moving and pay attention to what happens when we first hit the wall down here. There they are. Now, it looks really messy, but can you see that there are waves? I'm going to do it again. Waves that reflect off and start going back the other direction. You'll see them. Makes the pattern really weird looking. See, if you follow my mouse, it's going up right like this. Now, the reason it looks kind of weird is because we still have the waves coming down at the same time we have the waves going up. And so what we get here is called interference. That was the subject of our first little behavior. And that is when waves overlap. So the pattern's going to look really weird, okay? So this isn't the easiest way to see it, but it's actually pretty realistic. Now, what I'm going to do, let me clear these waves. I'm going to bend the wall a little bit up like this. And I want to show you how the reflection is a little bit different. So here come the plane waves again. And I'll follow it with my mouse. You see the line going up like this? Okay, I'm going to draw this on your page a little bit because that was, again, a little difficult to see. But follow it with my mouse where they first hit right here. And the waves start going in this direction, okay? And the interference pattern really messes things up. All right, so let's go back to this page here and describe what we're seeing here. So reflection, simply put, is waves bouncing off. Bouncing is actually just another word for reflecting. Bouncing off of a barrier. Okay, so they just have to hit something. They're not going to go through it. They're going to bounce off of it. All right. Now, here's why I said I think you could relate to this better than most of them. This is the one of the 5 that I think particles do almost exactly the same as what waves do. So I'm going to say a big yes to particles do this. All right. I'll show you an example of that in just a second. So let's draw the first couple because this is what I just showed you here. So on this first one, the plane waves are coming down. And then when they hit this, see how the barrier is parallel to them? So they hit kind of head on, you might say. The reflections, we'll draw the reflections this way. It's easier to see on my red ones. It's going to be hard to see when you're drawing in pencil. But that's what the reflections look like. They reflect straight back, and they look exactly the same as the original waves. But when we angled the wall a little bit, the reflection was not straight back, but at a little bit of an angle. So let's see how we draw these. The reflections move in this direction like that. Okay? So they're still starting out straight down, but the reflection is off like that. I want you to draw it carefully. I don't want you to draw the reflections parallel with the actual wall, okay? It's a little bit of a different angle. And the more that we angle the wall, the more the angle of the reflection. So let me show you. Get my ripple tank back here. Here we go. So I'm going to angle this wall as steeply as I can. Move it over into position. Okay, now there's going to be a lot going on here, so I just want you to focus on the reflections. See how they start kind of going almost down? So follow my mouse. That's the direction of the wave reflection. Okay, so I'll draw that again back on my page. So we still start with these waves in this direction, but this time the waves were actually moving somewhat, mostly left, but somewhat down like that. Now I want to show you another perspective of this. And when I said particles do this, again, think tennis balls when I say particles. So I want you to think how a ball will reflect off the floor. So if this is the floor and you throw a ball like this at the floor, let's say a ball is moving in that direction, we would anticipate that the ball will reflect off of the floor at a similar angle like that. This could also be a wall if you throw it off of a wall, or basketball players, they would maybe shoot the ball off of the backboard. If you're playing pool or billiards or something like that, you bounce the ball off of the side rail of the table. And if you go in at a bigger angle, here, let me do one like this. If you hit at a big angle like that, then you come off at a big angle as well, like that. Okay? Only if you hit directly straight at it does it bounce directly back in the same direction. And that's what we did here on this first one. Okay? So have a good picture of being able to predict the direction of the reflection here. All right, now we're going to put some curved walls in place. I'll show you that. Okay, so we're going to get some waves going here. Now I put this curved wall in place. Look at the reflection that occurs there. And I'm going to show it again. The first reflection, see how it bounces kind of sideways? So the part here on the right is bouncing towards the left, and the part on the left is bouncing towards the right. And they're all moving, if you notice, they're all moving to a point right up here. There's actually a really small little a white cross on there that you can see if you're up close. I don't know that you'd be able to see it. That is the point where all those reflections head, okay? So that's one type. Now let me clear this. I'm going to flip this around. I got to get right on top of it. There we go. I'm going to rotate it around so that it's facing the other direction. There we go. And now let's see how waves bounce off of that. See, kind of the opposite. Instead of coming to a focus, they actually spread apart. If you look at the first reflections, they're away from each other. All right. So back here again, let me draw these. So what we saw here is the reflections are like this, all heading towards this special point we call, I want you to recognize this name, a focal point. So the reflections are going all different directions when you hit a curved wall, but they're all heading towards that focal point. And then this last picture was what I showed you there at the end. They actually spread apart like that, head away from each other. So it's a good way to take a wave and spread it out. All right, and there's one other kind of interesting thing. Let me get it set up here and I'll show you. Okay, so I've gone back to this shape. We call this concave because it's kind of caving in away, shaped like a smiley face. And now instead of having plane waves, I'm going to have a point source up here, which will make circular waves, kind of like that. But I want to move the source of those waves to the focal point. Okay, so this little, if I can find it here, there we go. There we are. So now I'm going to make waves at the focal point and watch what happens when they reflect. You see this reflection right here? I nailed it almost perfectly. Perfectly straight and going back up. So I've turned these circular waves into plane waves moving back in the other direction. Very similar, but actually opposite to that fourth picture that we drew where we had plane waves, straight waves, turn into circular waves. All right, so they're moving them up like that. This is a great way to take a small source of waves and spread them out. All right. So again, let me draw this. This is not the easiest thing to draw. So I've actually drawn the circular waves being made at the focal point. The reflections would look like this. So I want you to know that those would reflect straight like that. Okay. So this is the source of the waves at the focal point of an inward curved barrier. All right. So let's think about why you'd want to do this. This is actually really common for acoustics. This is how we direct sound. For example, in an auditorium or on a stage, in an outdoor amphitheater, we can direct the sound waves made by the band or the musician or whoever's performing by putting curved walls behind them or behind the audience. And so we can kind of shape the sound, if you will. So this is how acoustic engineers figure out how to put different shapes into the auditorium. If you go to our auditorium, you'll see absorbing walls, but you'll see up on top, you'll see these what they call baffles that will direct the sound down to the audience through reflection, right? Kind of a neat application. So some real life examples. Anytime you have reflection of a sound wave, we call it an echo. If you have reflection from light waves, it's very often from a mirror. So we have mirrors of different shapes. If you look at a car, there's rounded mirrors on some cars and trucks. When ladies put makeup on, sometimes they'll have a little mirror that's curved. You might have a mirror in your bathroom that might be curved, although a lot of them are flat. If you look at a satellite dish on a house, there's a reason the satellite dish is shaped like this. It's because we want to reflect the waves coming from space, from satellites out in space, and direct them right towards what we call the receiver that's picking up the signal to send it to maybe your TV, and that receiver sits at the focal point, okay? Remember here that particles do the same thing, okay? So anytime, if you think of almost any sports example, I mentioned playing pool or basketball, but also any game where you're hitting a ball off of something, even golf and baseball and softball, although the bat is a little difficult to kind of aim quite right, but that's all about reflection, okay? All right, so I think this has gone on almost 13 minutes now, so I'll zoom out if you need to go back and repeat any part of that. That's fine. You can also find this simulation yourself. Just ask me in class how to find it, and you can kind of play with that a little bit yourself. All right. Thanks for watching this one. Bye-bye.